All right, so it's asking us here to figure out if xy satisfies the linear function. So is 6, 1 a solution to the equation y equals 6? So the thing we have to remember is that this coordinate is our x, y coordinate. That means that x is 6 and y equals 1. So we're going to write our equation, okay? Now instead of, all right, we can rewrite our point over here. Instead of 6 and 1, okay, instead of y equals 6, we need to plug 6 in for x. So this will go right here, and we will plug 1 in for y. So we're going to plug this into our equation because it wants to know, is this a solution to the equation? Well, if it is, both sides will equal each other. 1 equals 6. Does 1 equal 6? Well, that's obviously no. So we would click no. Okay, and we would submit this. If the sides don't equal each other, it is not a solution. All right, let's move on to one that's maybe a little more difficult here. So we have is 0, 0, is 0, 0 a solution to the equation y equals negative 8x. Okay, and just like the title of this tells us, okay, this is our x, y coordinate. Now in this case, they're both the same, so it doesn't necessarily matter, but we're going to plug in 0 for x, and we are going to plug in y. We're going to plug in 0 for y. So it will be 0 equals negative 8 times 0. Remember, whenever we have an x right there next to our number, when we have a coefficient and a variable, they're multiplying by each other. So we have 0, nothing happens on the left side, and then we have negative 8 times 0. We know that 0 times anything is just 0, so 0 equals 0. Does 0 equal 0? Yes, it does. Obviously 0 equals 0. So, yes, 0, 0 is a solution to y equals negative 8x. Okay? Now we have, does the point 0, 39 satisfy the equation y equals 90 times x minus 39? Okay, we will take 0, we will plug it in for x, and we will take 39 and plug it in for y. And we need to see if this ends up equaling each other, if both sides end up equaling each other. So I plug in 39 for y, I substitute it in there. I have 90 times 0 minus 39. So obviously the left side is just 39, stays that way. 90 times 0 is 0, and then I need to bring this negative 39 but down, so minus 39. Well, 0 minus 39 is negative 39, so we have 39 equals negative 39. Do those equal each other? If I asked you, would you rather have $39 or negative $39? You can make a decision there because they're different, okay? These are different. These do not equal each other. So for this one, you would put no. The point 039 does not satisfy the equation y equals 90x minus 39. Okay? Does 0 negative 708 satisfy this equation? Well, here, right, remember this is our xy coordinate. Here, I only have one variable to plug in because there's only a y. So I have negative 708 equals 708. Those don't equal each other, okay? That does not equal each other. So I'm going to put no. Okay, negative 708 and 708 are not the same. That is clear. Okay. All right, let's do one more here. We have y equals x minus 32. And we want to know, does 309, 275, does that point satisfy this equation? Well, I'm going to plug in 309 right there. And I'm going to plug in 275 in for y. So 275 equals 309 minus 32. Well, the 275 is going to stay the same, and I need to take 309 minus 32 and figure out what that is. 9 minus 2 is 7. I'm going to borrow here. 10 minus 3 is 7, and I'll bring my 2 down, so 277. Is 275 equal to 277? Obviously not. Okay, obviously not. So that is how you figure out if the point xy satisfies the linear function. You just take the point, plug it into the equation, and see if the two sides equal each other after you calculate out the equation.